Hello children, let's start our session, metals and non-metals. Till now, that is last session, we have learnt about reaction of metals and non-metals with acids and bases. Today, we will be learning about displacement reaction, that is metals and non-metals, both they undergo displacement reaction, and also we will be learning about uses of metals and non-metals. Now let's start with displacement reaction. Displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its compound. That is, element here it indicates whether it can be metal or non-metal. So displacement reaction is a chemical reaction in which more reactive element displaces a less reactive element from its compound. Both metals and non-metals take part in displacement reactions. For example, reaction of iron nails with copper sulfate solution. This experiment we have learned in 7th standard. When iron nail is kept in copper sulfate solution for some time, we can see the color of copper, the solution change, as well as we have seen that reddish brown coating on the surface of the iron nail. What is the reason for this? When iron nail is kept in the copper sulfate solution, here we can see that first jar which has copper sulfate solution, the color of the solution is blue color, and when it is kept when iron nail is kept in copper sulfate solution, it undergoes displacement reaction, and as here iron is a most reactive metal than copper. As it is most reactive, it displaces copper from its compound. That is, here the compound is copper sulfate solution. So it displaces copper from its compound, and the displaced copper is getting deposited on the iron nail, and the solution becomes ferrous sulfate or iron sulfate. So the color of the solution changes from blue to green color, and we have seen that the displaced copper is getting deposited on the iron nail. So this shows that whenever most reactive metal and where most reactive metal can be, it displays a less reactive metal from its compound. So this what we call that as displacement reaction. And here again I repeat, when iron is kept inside the copper sulfate solution, as iron is more reactive than copper, it displaces copper from its compound, that is from copper sulfate solution, and the displaced copper is getting deposited on the iron nail. So the solution becomes, after chemical reaction gets completed, the solution becomes iron sulfate. So we can see the color change in the solution, that is from bluish to green color, and copper which get displaced by iron, it get deposited on the iron nail. Fe plus CuSO4 gives Cu plus FeSO4. Fe, that is iron, plus CuSO4, that is copper sulfate, when gets reacted, it gives copper Cu plus iron sulfate or ferrous sulfate, that is FeSO4. This displacement reaction we can learn with one more example, that is zinc when it reacts with copper sulfate solution. Zinc is more reactive than copper. So when zinc is reacted with copper sulfate solution, it forms zinc sulfate. That is, it displaces copper from copper sulfate solution. So it forms zinc sulfate, and copper will be displaced separately. Zinc is a silvery white color, and as we know that color of copper sulfate is blue in color. When the reaction gets over, the solution becomes colorless. That is due to the formation of zinc sulfate, and we can see that brown, reddish brown color deposits on the bottom of the beaker. This is due to more reactivity of zinc than copper. Then what will happen if zinc sulfate is taken and if copper is placed in it? Can the reaction, displacement reaction takes place? No, as we have seen that zinc is more reactive than copper, then zinc only can displace copper from its compound. But when zinc sulfate solution, copper is placed, copper cannot displace zinc from its compound because copper is less reactive than zinc. So if it is placed, if copper is placed in zinc sulfate solution, there will be no reaction. So let's study the chemical reaction. Zinc, that is Zn, plus copper sulfate, that is CuSO4, gives zinc sulfate, that is ZnSO4, plus copper, that is Cu, that is silvery white color. Zinc is silvery white and copper sulfate is bluish in color, and after reaction gets over, color of the solution becomes colorless. That is, zinc sulfate is colorless solution, and we can see that brown color deposits on the bottom of the test tube. But what will happen when copper is placed in zinc, the zinc sulfate, there will be no reaction. What is the reason behind it? Because copper is less reactive than zinc. So from this example, we have learned that first example, when iron nail is placed in copper sulfate solution, iron displaces copper, means iron is more reactive than copper. And in this case, when zinc is placed in copper sulfate solution, zinc displaces copper from its solution, means zinc is more reactive than copper. So from this we can conclude that this with among these three elements or metals, we can say that that order of reactivity is zinc, then iron, and then copper. That is, zinc is more reactive than iron than copper. Can copper displace zinc from zinc sulfate? No. Can copper replace iron from iron sulfate? No, there will be no reaction because copper is less reactive than zinc as well as iron. Now we will be learning this by one more activity, that is, we have to take 5 beakers, name the beakers as A, B, C, D and E. Now first beaker A, we have to take copper sulfate solution. That is, solution is copper sulfate. As we can see here that A beaker consists of blue color solution, that is copper sulfate. In copper sulfate, this beaker A, we have to add few granules of zinc in it. Then the beaker B, we have to take copper sulfate solution. So we can see here it is bluish color, and in this we have to put iron nail. See here down, iron nail. We have put iron nail in beaker B with copper sulfate solution. Now C, beaker C, we have to take zinc sulfate. That is, already we have learned that zinc sulfate is a colorless solution. So here beaker C, this is colorless because zinc sulfate is taken, and in this we have placed some copper turnings, that is very thin foil of copper, what we call that as copper turnings, is placed in beaker C. And in beaker D, this brownish solution, what we call that as iron sulfate or ferrous sulfate solution, again ferrous sulfate solution, again here in this some copper turning is added. Now in beaker D, take zinc sulfate and some iron nail is being added. Now keep this beaker set up undisturbed for some time. After some time, what we can observe is beaker A, the color of the beaker, that is where copper sulfate and zinc granule, copper sulfate solution in which zinc granule is added. We can see that zinc, as it is more reactive than copper, it displaces zinc, displaces copper from copper sulfate, and it results in the formation of zinc sulfate and copper. So zinc sulfate and copper, you can see the brownish reddish brown deposits at the bottom of the beaker. And next in beaker B, where copper sulfate solution and iron nail was placed. Here also we can see that the color of the solution changed from blue to green, which indicates iron displaces copper from its compound, that is copper sulfate solution, and it forms iron sulfate and copper separately. That is why the color of the solution turned into greenish color, blue to green color. And what about the remaining three beakers, C, D and E? These three beakers remain unchanged. There is no reaction takes place. Why there is no reaction takes place? Because in beaker C, we have taken zinc sulfate and copper turnings. As we know that copper is less reactive than zinc, it cannot displace a zinc from its compound. The same way in beaker D, we have taken iron sulfate with copper turnings. As copper is less reactive than iron, it cannot also displaces iron from its iron sulfate solution. And in beaker E, we have taken zinc sulfate and iron nail. As iron is less reactive than zinc, it cannot displace zinc from its solution. So in beaker C, D and E, we can see there is no change in the experimental setup because there was no reaction. There is no reaction takes place. So from this we can understand displacement reaction is a chemical reaction in which a more reactive metal can displace a less reactive metal, or more reactive element can displace a less reactive element from its compound. It is called as displacement reaction. Now, how do we come to know this order of reactivity? Here we have seen only among three elements, three metals like zinc, iron and copper. That is, zinc is more reactive than iron than copper. So we have arranged this order: zinc, iron and copper. Now, if you see that reactivity, how to remember that reactivity series? If you keep this saying in your mind, you can easily recollect the reactivity of, you can arrange the reactivity of reactive metals arranged in order from most reactive to least reactive. That what is the saying? Please stop calling me a careless zebra. Instead, try learning how copper saves gold. You can write and keep this. Please, P stands for potassium. Stop, S stands for sodium. Calling, Ca, that is stands for calcium. Me, M stands for magnesium. A for aluminium. Careless, Car, carbon. CR stands for carbon. Zebra, Z stands for zinc. Instead, that is I stands for iron. Try, T stands for tin. Learning, LE, that is LEA, you can take LE, stands for lead. How, H stands for hydrogen. Copper, that is same word, you can keep copper. Saves, S stands for silver. Gold, you can keep gold as it is. So if you keep this order, please stop calling me a careless zebra. Instead, try learning how copper saves gold. So in this, if you see that potassium, sodium and potassium, as we know that they are very reactive metal. So it is at the top, most reactive metals. And if you see that last silver and gold, we call that as they are non-reactive element, non-reactive metals. That is why that they are at the bottom of the reactive series. So this way you can keep in this mind and you can arrange. Suppose if you take this potassium and some magnesium compound, that is magnesium sulfate. So potassium, as it is more reactive, it can replace magnesium from its compound and it forms it can displaces magnesium from its compound. But if magnesium is taken and if potassium compound, magnesium cannot displace potassium from its compound because magnesium is less reactive than potassium. So from this we can understand the displacement reaction is a chemical reaction in which a more reactive element can displace a less reactive element from its compound. Now next move on to our next topic, that is uses of metals. Uses of metals, as we have already learnt about physical properties of metals like hardness, malleability, ductility, conductivity, sonoricity, etc. May we use metals in our day-to-day life in different ways. For example, metals can be used in industries, automobiles, car engine, car parts, machineries, and it's used in musical instrument, cooking utensils, conducting wire, etc. Now we'll see one by one uses of metals, what we use in our daily life. So that is, first let us take gold and silver, as we know that they are non-reactive metals. So gold and silver are used for making jewelry, because we know that gold and silver can be malleable as well as can be, they are ductile metals, so it can be drawn into thin wire shape or any this, so that easily we can make jewelry, as it is less reactive and it doesn't lose its shyness. So copper and silver are used for making jewelry. Gold and silver are used for making jewelry. Next, coming to copper. Copper is used for making electrical wires, cooking utensils, etc. Because copper, due to its property ductility, it can be drawn into wires, and as well as it has a good conductor of electricity. Because of these two properties, it is used for making electrical wires, and as it contains this property malleability and conductivity of heat, thermal conductivity, it is used to make sheets and making cooking utensils, as well as it is used for cooking purpose, making cooking utensils. So copper is used for cooking utensils due to property of malleability and conductivity of heat. Copper is used for making electrical wires due to its property of ductility and conductivity of electricity. So next metal, let us see about zinc. As zinc is coating of zinc on iron article. This we have learned in 7th standard. What is this process? Coating of zinc on iron is called as, it is called as galvanization. And what for it is used? Because it is used to protect iron from getting rusted. So zinc is mainly used as a protective coat for iron in order to prevent it from rusting. Next we'll see about aluminium. Aluminium is used for making electrical cables, packaging, cooking utensils, etc. due to its property of conductivity of electricity. Packaging, it can be made into very thin foils by the property of malleability. It is used for cooking utensils because it has a property of conductivity of heat, etc. Now next, metal like iron and steel, they are also widely used in buildings and home constructions. Now next, liquid metal. Only metal which exists in liquid form is mercury, which can exist in liquid form at room temperature. as we know that it is used in clinical thermometer. Next, lead is commonly used in car batteries, and coins which are that what we use, which are made up of a metal called nickel. And sodium metal, as we know that it is a very reactive metal, it is used as a table salt, that is sodium chloride, NaCl, we called as common salt. So sodium is used for making table salt. Now next is uranium. Uranium are commonly used in defense, that is used to make atomic weapons, nuclear weapons, etc. So this way, if you keep discussing about uses of metals, we can discuss a lot. Now let us move to uses of non-metals. Here what we see is diamond. First, non-metal diamond. Diamond is a form of carbon. It is mainly used to make jewelry. Diamond is used to make jewelry. And here this we can see about sulfur. Sulfur is used to make matchstick tips. The tip of the matchstick is nothing but that sulfur. Sulfur is used to make matchstick tips, and sulfur is also used in making paint as a main ingredients in making paint. So use of sulfur, we can write sulfur is used in matchstick, that is tip of the matchstick consists of sulfur, and sulfur is also used in making paint. Now let us discuss some more uses of non-metals. That is non-metal, as very familiar, non-metal oxygen. As we know that oxygen is very important for us for breathing. Oxygen is used for breathing. Next, coming to one more, during respiration, what is exhaled? Carbon dioxide. So if you think about uses of carbon dioxide is used by plants for photosynthesis, for preparation of food. So we can write that also. Carbon dioxide, use of carbon dioxide is used by plants for making their own food. And next, non-metal chlorine. Chlorine is used for purifying water, chlorination. This also we have learned in 7th standard, for purification of water, that is water treatment plant. That one process of this chlorination, that is chlorine is used for purifying water. And next is phosphorus. Phosphorus is used in making crackers. And so non-metal sulfur is used in tip of the matchstick, and phosphorus is used in crackers. And non-metal like nitrogen. Nitrogen is very important for the growth of plants. So atmospheric nitrogen cannot be easily absorbed by plants. So this we have learned already as nitrogen fixation. And in order to get more crops, farmers apply fertilizers, that is mainly made by nitrogen. So nitrogen is used in making fertilizers. And graphite, as we have already learned in property of non-metal. All non-metals, they are bad conductor of heat and electricity. Exception we have learned graphite. It is one form of carbon. It is used as a good conductor of electricity. In batteries, it is used as one of the electrolyte, this used electrode in battery. Electrode in battery is graphite is used as electrode in battery. So it is used as good conductor of electricity. And now next, coming to potassium. Potassium is used in fertilizers. And nitrogen, again it is used by plants, as we have already discussed. And graphite is also making pencil lead. And carbon is used as fuel. And bromine is used in dyes and pesticides. So these are all some uses of non-metals and important non-metals that what we have used. And you can even you can think of by your own, and you can write some more non-metals and its uses. So children, we have completed our chapter and today we have learned about displacement reaction and uses of metals and non-metals.